Let's take a look at topic 6.6, exponential and logarithmic equations, and introducing the property of equality for exponential functions, or equations, excuse me. Suppose b is greater than 0 and b does not equal 1. Then we could say b raised to the power of x equals b raised to the power of y if and only if x equals y. And we kind of saw this, we used this when we were evaluating logarithms in topic 6.3. So if you have the bases are the same and you know that they are equal to each other, well, that means the exponents would also need to be equal to each other. So let's go ahead and apply this property. Example 1, we're going to solve this equation. Now, notice, as it stands, I don't see a common base. But what I can do is I can rewrite each side of the equal sign with a common base. When I see 1/2, I'm thinking 2 to the negative first power. Looking at 4, I could also write 4 with a base of 2 as 2 squared. So let's do that. 1/2 can be written as 2 to the negative first power raised to the x plus 7 equals, and let's write 4 as 2 squared raised to the 3x power. And now what I'm going to do is I'm going to use my power of a power property, and I'm going to multiply my exponents. So this is 2 raised to the negative 1 times x is negative x. Negative 1 times 7 is negative 7 equals 2 raised to the 2 times 3x is 6x. And so now I have common bases. And now I can apply that property of equality for exponential equations. I'm just going to set my exponents equal to each other. Negative x minus 7 equals 6x. And I'm going to solve. This is a simple two-step equation. Let's add x to both sides. This is negative, so we'd add it to both sides. So I get negative 7 equals 7x. We divide out that 7. Negative 7 divided by 7 is negative 1. Negative 1 equals x. And here are your try-its. I recommend copying these down. You can pause the video and then come back and check your work. Okay, so let's take a look at this. We have 25 raised to the power of 3x equals 125 raised to the power of x plus 2. I want to write each of these, both sides of the equation, with a common base. So right away I'm thinking 25 is 5 squared. 125 is 5 cubed. So let's rewrite 25 as 5 squared raised to the 3x equals 125 is 5 to the third power raised to the x plus 2. And now let's use our power of a power property. This is 5. 2 times 3x is 6x. Equals 5. 3 times x is 3x. 3 times 2 is 6. And now my bases are the same. If my bases are the same, we're saying that these two sides of the equation are equal. That means my exponents would also have to be equal. So I've got 6x equals 3x plus 6. Let's subtract the 3x from both sides. I get 3x equals 6. And if we divide out the 3, 6 divided by 3 is 2. We get x equals 2. And now let's take a look at b. So on b, I've got this decimal, and the right side of the equation is already written with a base of 10. Well, I'm thinking, how can I write this decimal with a base of 10? Well, my decimal moved to the left if I had a whole number. So this is going to be, we can say this is 10 to the negative third power equals 10 raised to the 6x. And now I can just set my exponents equal to each other. -3. Oop, why did I write a 6 there? That should be a 0. Equals 6x. And we're going to divide out the 6. I get -3 over 6 equals x. And we can reduce that down. So this is -1/2 equals x.